The domain of a function is the domain of the algebraic expression, that is, the set of all real numbers for which the expression is defined as the real numbers. For example, find the domain of the function, express the answer in the interval notation. For the first function, f of x equals 1 divided by x squared minus x. Now, as we know, we cannot divide by 0, so the denominator here in this case cannot be equal to 0. So first, we set the denominator to not equal to 0. And solve this equation. So in order for this equation to be defined, x cannot be equal to 0 or x cannot be equal to 1. So how would you write this as an interval notation? So here's our number line, here's 0, here's 1, and we just do not want this 2 points. The rest is okay. So the domain here is from negative infinity to 0, we do not include 0, union with 0 to 1, do not include 1, and from 1 to infinity. In the next problem, in order to take the square root, everything under the square root, the expression under the square root have to be greater than or equal to 0. And as we learned from the previous topic, we will set this equation equal to 0 and solve for x. Next, we will make the table Next, we will make the table with the interval and test point to find out where the interval that would lead to this expression greater than 0. In the first interval, from negative infinity to negative 9, if we choose x equal to negative 10, which is in the interval, the first term, first factor, x plus 9 is negative, x minus 4 is negative, so the result is positive. The next one, positive, negative, negative, positive, 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 would mean the interval in which x squared plus 5x minus 36 is greater than or equal to 0 is this interval from negative infinity to negative 9. And because we want it to be greater than or equal, we include the endpoint and union with 4 to infinity. So this is the domain of that function. In the next problem, we are looking at two things. We have a square root and we have a denominator. So in order for this function to define, 2 plus x have to be greater than or equal to 0 and 3 minus x cannot be equal to 0. So in order for 2 plus x to be greater than 0, x have to be greater than or equal to negative 2. And here x cannot be 3. So let's take a look at the number line itself. here's -2, here's 3. Well, if x have to be greater than or equal to -2, and x cannot be 3, so we exclude this point. Okay, so how do we express this as the domain? Well, we have the domain here is including the -2 to 3, and we want to exclude 3, so we don't include the point. So here we got our domain. Okay. There is 4 ways to represent a function. You can represent a function verbally, algebraically, or graphically. So verbally, you can use the wording, right? Algebraically, it is the formula. Graphically, it is the graph. And you can also use the table value. That's the third way. So the next one, to evaluate f of x, divide the input by 3 and add 2/3 to the result. So we want to represent this function in algebraic, numerical, and graphical representation. So let's start with algebraic. Divide the input by 3 and then add 2/3 to the result. Numerical. We make the table the value. You can pick any value for x. And you can graph. When x equals -1, y equal to 1/3. When x equals 0, y equals 2/3. And when x equals 1, y equals 1. So then we have this line. Let's take a look at application problem. Because of the curvature of the Earth, the maximum distance d that you can see from the top of building or from an airplane at the height 8 is given by d of 8 equal to square root of 2r8 plus 8 squared, where r equal to 3,960 miles, that is the radius of the Earth, and d and h are measured in miles. First, we want to find d of 0.1 and d of 0.2. How far can you see from the observation deck of Toronto CN Tower? That is 1,135 feet above the ground. So first we have to change that feet into mile. and that is 0.215 mile. Then we substitute this value into the equation to find the distance d of 0.215. And that is about 41.3 miles. So on top of the observation tower, you can see as far as 41.3 miles. Okay. A commercial aircraft fly at a latitude about 7 miles. How far can the pilot see? You can start by evaluate d of 7, and that is equal to 235.6 miles. You want to find the net change and evaluate the distance d at each change from 1,135 feet to 7 miles, which means you will find the difference between d7 minus d of 0.215, and that is equal to 235.6 minus 41.3, and that is 194.3 miles. So for this problem, we will split the function into 3 pieces. So f of x equal, so the first piece is when you're driving between 0 miles per hour and 40 miles per hour. The next piece is when you're driving between 40 miles per hour to 65 miles per hour, and the last piece is from 65 miles per hour and up. Okay, so if you are driving between 0 to 40 miles per hour, so your speed is less than 0, so the amount of fine is $15 multiplied with 40 minus x. Now, if you're driving between 40 to 65 miles per hour, then you didn't violate the speed limit, so the fine is 0. If you ride more than 65 miles per hour, then the fine will be 6 by 15 times x minus $65. And let's say we want to evaluate f of 30. So f of 30 is in between 0 and 40, so that's 15 times 40 minus 30, and that is $150 that you pay because you ride 10 miles below the speed limit. After 50, so after 50, well, 50 is between 40 and 65, so you didn't have to pay any fine. After 75, and that is 10 miles above the speed limit, so you are paying $150.